Hey, you wonderful earth science kids. This is Mr. Johansson here, and I just want to do a brief thing on density. And I've given a fair number of things on density already, but I wanted to show you here how you'd work out the problems algebraically and then give you a real simple way of remembering this. It's kind of a trick. I don't really like tricks. It's good if you could do the algebra. So let's do that first. Density equals mass over volume. So if you were asked a density question, you would just use that formula. Divide mass by volume. Great. But what if you wanted to find the mass? If you were given the density and the volume and you were asked to find the mass, how would you get that? Well, to get mass all by itself, multiply both sides by V. In this case, the V's cancel out, so you'd have mass equals density times volume. Great. Nice and easy, and that's good algebra. Okay, but what if you were asked, let's go back to the original question, density equals mass over volume. What if you were asked to find the volume now? Now you got to do two steps in your algebra. Okay, first, you have to get the volume on the top. If you solve for reciprocal volume, that's volume on the bottom, that's not helping you. So you have to get volume on the top. So you do the same thing you did before, all right? Density times volume equals mass. So density times volume equals mass. But now you have to get volume by itself, so you simply divide both sides by the density. The density cancels out here, and you have volume equals mass over density. It works like a charm. Now, here's a trick. Don't tell anybody. Shh. Imagine, maybe close your eyes for a minute. Imagine the Delaware Valley building, the old Delaware Valley School near Callicoon. Now, maybe you've never seen it, so picture a majestic, gorgeous, beautiful school building with high towers and clock towers and all that stuff, and picture it late at night and the full moon rising up behind it. Can you picture that? Beautiful Delaware Valley School with the moon rising up behind it. Now, if you can keep that in your mind, you can write the moon rising up over Delaware Valley. Make a triangle like that. Now here's the cool part. If you're looking to solve for the mass, cover the mass. What do you need to do? Density times volume. If you need to solve for the density, cover up the density and you have mass divided by volume. If you're trying to solve for volume, cover that up and you have mass divided by density. It's a good trick. Shh. Okay? So let's do an example. I want to do a fairly challenging example. What if you wanted to find the density of this? This is a piece of shale. We'll be studying this. It's a piece of shale. What's the density of it? And you can see it's an irregular solid. So I can't just measure it like a cube. That won't work. What I can do is take a graduated cylinder, fill it with a volume of water, and if I know the volume of water, and in this case, it's exactly 200 milliliters. Now, I made the water blue so it's easier to see what's going on here, but I don't know if you could see that, but it's exactly 200 milliliters. If I take this and I drop it in, well, the increase in volume, that will tell me what the volume here is. The difference between the original volume and the new volume has to be the volume of that. But before I do that, don't you think I should take the mass as well? Well, I put this on a triple beam balance, and I'm sure you know how to work a triple beam balance, and if not, I'll show you in another video. Or we do have electronic scales, and those you simply turn on and put this on it. Hey, and you get the mass of it. And the mass of this was 49 grams. It was 49 grams, right? So if we're looking for it, density equals mass over volume. Whenever we're solving, we write the original formula down first. That's an important step. And then you substitute the numbers in. So equals 49 grams, but divided by what? By what? Well, when I drop this in, should I just drop this in plunk? Won't that splash some of the water out? Won't that destroy my ability to read this, if I lose some of the water, it will. Can you think of what we should do? Perhaps if I tilt it like this, put the sample in and let it slide down in nicely. And now, the first thing I need to do is find out what each of these lines means. Well, I see 200 here, I see 250 here. There's 10 lines between them. If it goes from 200 to 250 with 10 lines, can you think of what each line is worth in terms of milliliters? Bet you can. Each line would be worth, go ahead, you got it, 5 milliliters. 5 milliliters will get me in 10 lines up to 250 milliliters. So I look at it very, very carefully. I see it's more than 3 lines, less than 4 lines, but it's kind of close to the 4 lines. I'm estimating that it's about 3 milliliters up the 4th line. So I have 3 lines that it went up. Those are worth 5 milliliters each. That's 15 milliliters. And then I believe it went 3/5 of the way up. That would put it at about, and all I could say is about. This is not going to be great measurement, but it's good enough. So it's about 18 milliliters. So if I take my calculator and turn it on, and I say 49 divided by 18, look at what that equals. About 2.7 grams per milliliter. Now see all those extra digits there? Do I have any right to report those extra digits? Listen, I'm not even so sure it's 2.7. That milliliter measurement was a little uncertain. So I could say 2.7, but I know that 7 is a little bit iffy. Could I ever say 2.72? No, that would just be silly. So I report equals 2.7 grams per milliliter. And that's all it is. That's how I would do that. And that's a density calculation. I hope this helped. Thank you very much for watching.